Nudds, Professor Emeritus from the University of Guelph. I have a few of his credentials here, but I also have a personal note to have. Tom was BSc and MSc at the University of Windsor, did his PhD with the late Dave Ankney at the University of Western Ontario, now known as Western University for those of us in Ontario. He's currently Professor Emeritus from the University of Guelph. His research is focused on conservation and resource management issues, as well as community ecology of waterfowl in the past. He currently works on species and risk policy and works particularly with stakeholders, non-academic stakeholders, to try to solve questions of conservation concern. He's worked on a number of committees related to endangered species and conservation. Tom was on my advisory committee as a graduate student in the mid-90s when he was at the University of Guelph. And he was also on the committee for Jackie Liskis, who's also...
I'm sorry. I couldn't stop.
And Tom was always a wonderful mentor in terms of upholding the integrity of the scientific method, the hypothetical deductive approach to science, one that I have taken to heart myself in my own work and that of my students, and I know that Jackie has done the same. So, Tom is a bit of a curmudgeon. He's a bit of a maverick. So I look forward to hearing about this, what he has to say today about endangered species. Thank you. Oh, I guess I should read your title. On evidence and inference, how, quote, science-based is species at risk assessment, listing, and recovery. I should say that he was a bit scared that Justina was speaking today, and he sort of gave me a bit of the gears that he was going after Justina, but as I said to him, ladies first.
It was a joke. No, as always in Elbrick's, wisdom, the wisdom of setting up Justina and Marty just before this, it was perfect. Justina put up a model of a better system to aspire to that doesn't have us sort of steeped in the slavery of single species assessments, wrestling with some of the uncertainty, the way that she described, and so on and so forth. Marty followed with an excellent description of sort of the mechanics, which I assume she would do, so I can jump straight to a flow chart. Because she introduced some of the mechanics of this and introduced some of the issues around how CSWIC deals with scientific uncertainty. And that's been a question that I've been concerned with a lot. But while I was standing there looking like I was chomping at the bit ready to get up here, and then it would look silly to sit down, I just stood there. I was chomping at the bit because the questions coming from the audience here, I'll just say I think are teeing up what I would have said. Those are excellent answers, but what I would have said too in response to this. So listen throughout the talk. If you don't hear that I've sort of pinged your question, ask it again or something. But I want to take us into this whole realm of stakeholder engaged, collaborative and decision analysis and adaptive management. You know, it's been said that adaptive management's easy to understand, almost. So we're going to go there. It's everybody talks about it. But it's always the last sort of thought in a big long list of things to do, right? And oh yeah, we're going to do this by adaptive management. Rather than infusing the very philosophy of the approach, which is fundamentally science-based, into the whole decision-making and management framework by which we evaluate the efficacy of policies that are developed out of a collaborative, multi-stakeholder sort of engagement with the process, okay? So that's where I want to go. So thank you for setting me up.
right.
Whoop, sorry.
There you go.
You did give me the instructions already. I forgot already. Yes. So this isn't so much an outline in the linear set with Justin Justina said. This is the third of the linear talks this afternoon. So, but I don't. I'm sort of. It's sort of going to be the line I'm going to go down. These are the topics I'm going to touch on. I'm going to touch on this business of evidence. I'm going to take my cue from where sort of Marty ended off on the evidence. I'm going to show you some research that's been done recently out of a couple of grad students in our department. I won't show you the earlier grad students' work, but I'll show you the later one, lady by the name of Laura Trout, who has done an extraordinary amount of research ferreting out information. I mean, the woman is a ferret. Out of status reports. It's just unbelievable what she did. I'll talk about inference, and I want to talk about the logic systems of science and of law. Okay, this is where I really get out of my comfort zone, but I have run this by I will say, in an organization much like you guys have here of philosophers and humanities folks and scientists together, I have run this thesis by them, and the philosophers, in what is high praise for philosophers said, I'll have to think about that a little bit more, as opposed to get out of here. So I thought that was pretty good. So now I'm ready to go on the public stage with it. Just leave my philosophy friends at Guelph behind. So we're going to go into I'm going to go on some thin ice there. I want to really emphasize that once we talk about differences about inference, why status and threats as they appear in status reports are in fact hypothesized states of nature and their causes. Marty alluded to this a little bit. We talked about threats at the end, but they're hypothesized states of nature and their causes. They're not conclusions in the way that we make inferences based on evidence in law and act. Okay, there's a key difference in how we assess evidence in science versus law. Then I want to talk, in order so we get down here, I have a modest proposal for resolving uncertainty-generated gridlock and what I call precautionary paralysis, where either, as Marty talked about, it comes back from the minister, not often, and says we won't list it, or it sits there for 4 years, 9 years, or whatever on the minister's desk while everybody's threatening lawsuits back and forth at each other. Hurry up and get it done. Well, no, we can't. Well, right? Just ridiculous. Increasing risk. All kinds of risk. Right? Not just to the species, but also in terms of resources unnecessarily spent and so forth. So all of this, I'm going to say a little bit of history. I'm going to say all this in the context that over time, from the history of sort of the way humans interacted with resources in the natural world, by and large from the evolution of the wide use movement in the early part of the last century, right? Constituencies of resource users had advocates in government for those groups. So you had your trappers and your hunters. You had your anglers, you had your commercial fishermen. You had your foresters, forestry department looking after your foresters. The advent of ecosystem-based management, biodiversity, and all these kinds of concepts has changed the game for the civil service, for those bureaucracies that we all quibble about from time to time. Along with that, too, has also come the emergence of very sophisticated user groups that don't take no for an answer, or don't take yes for an answer, and come with their own data analysis to the table, right? There's an enormous capacity, learning capacity out there in the world, and as the governments are devolving, or investing more and more in education and in health and so forth, and the agencies now responsible for a bigger mandate than they ever had before, not just natural resources that we use, but also biodiversity for its own sake, right? Species with their own inherent value. You've got to look after all this kind of stuff with smaller and smaller budgets, and those agencies that are left to do that, how are we going to do that big job, right? All partitioned off into our little sectors and feuding with each other over the evidence, when there might be a better way forward. So, this is a figure from Laura's thesis, and Marty's by and large gone through, but there's the quantitative criteria that she talked about. And over here we have up here we have the rescue effect that she talked about, and she mentioned how something that ends up categorized as, let's say, endangered, after we consider whether or not there's a potential rescue effect, the risk could be down, it could be down designated to a threatened or remain endangered. Similarly, here a species might be, based on all these criteria that Marty explained, could be threatened, but the rescue effect could, if there's little potential rescue effect, it would stay as threatened, or it could be down designated to special concern, and so on and so forth. And in a lot of cases, this is sort of at least quasi-quantitative sort of information. So it's colored yellow here like this, but in a lot of cases it could also be colored pink. And here's these qualitative criteria. And then, so Marty talked about these two categories, but I'm not entirely sure I heard, and I thank Justina for constantly reminding me that it doesn't really work like this, right? It isn't really like, okay, we assess all the quantitative stuff, and then there is this phase where we sort of sit and reflect on it in a formal sort of way. At the end of the day, the committee sits back and says, on the whole, what's our expert opinion, given what we feel about the quality of the data over here, and we heard all about the challenges of that and so forth. How do we feel about our overall final assessment, and compare that to the definition of the category, and then it gets, the recommendation goes forward to the minister with that, and if there's some reason that based on these, it ends up in a different category, it's supposed to be accounted for in the status report, right, with an explanation. Now, but this is written like this because this is meant to be generic, right? Although some of the details are COSEWIC specific, because we wrote an algorithm for the computer, okay, to take the human out of the equation. Hold it, I know I'm in a humanities conference, but let's just pretend for a moment we take the humans and that expert opinion away. And we just ask, if there was nothing but the numbers, what would the answer be? So we can try to isolate that effective expert opinion, which, in a non-stakeholder engaged, non-collaborative kind of decision-making framework, at least not formally so. I'm not saying COSEWIC doesn't do everything in its power to be open, it's mandated to be open and share its results with people. But when the appearance to the average stakeholder, I think there was a question over here, is, man, that's not my experience, how'd they come up with TH? Like in my neighborhood, it's NR. And then it starts, right? And Marty gets her emails and stuff, and when they should be going to the other party. So we wrote this algorithm to separate, basically, that, and then Laura went to the back of assessment reports, 374 for all the vertebrates up until that were assessed between 2001 and 2012, comprised 374 vertebrates. You went through them all, and she extracted the values for each of the 34 ecological variables that you can find at the back of those assessment reports. We put them through the algorithm and said, what did this decision-making algorithm produce? And then we compared it to the COSEWIC final designation. Okay, so it's kind of like an experiment. We can kind of control for the effective expert opinion that outsiders don't see. You can go to the meeting, you can watch, you can do all that kind of stuff, but the average stakeholder doesn't have the resources to go to those things either all the time, right? And so there's always this mystery about what comes out of the black box and everything. We've all experienced that. So we used these data for algorithm input, and here's the results, violating every rule of a PowerPoint presentation and throwing tons of numbers at you. The only point I want to make is, really, it's about Laura, the ferret. 374 status reports later, here we have produced for each of these vertebrate groups, and all of them together, what the algorithm predicted threat status was, and what COSEWIC final designation was. There's no implication here that one is right or one is wrong. Let me make that absolutely clear. Okay? That's not what we're doing. We're trying to ask, what is the effect of expert opinion on modifying the... In other words, turn the question around. How far could we get if all we did was just deal with the quantitative stuff, and we didn't have to invite all that other stuff that comes? Everyone could agree those are the numbers. Now, there might be issues with the numbers, but we could at least agree those are the numbers, the best available numbers. And so up here we have, these would all be up designated relative to what the algorithm produced. These would be down designated to what the algorithm produced. And the ones along the diagonal get returned, the algorithm returned exactly the same as Kosiewicz did, okay, was Kosiewicz' final designation. Now the 374, you can see here that over half of them, about half of them, all returned exactly the same thing. Okay, so we got this, they got the same information out and so forth. Half lay off the diagonal. But there was no tendency for there to be any up designating versus down designating. Like that, the quote unquote error, and I use that term in a regression sense. Okay, the residuals are equally distributed around the line. Okay? So, that's fine, because as Marty pointed out, expert opinion is considered at the committee level, right? And so, for example, you know, Laura searched all of those status reports for statements like this. This beast met EN under criterion C, which was this, but was designated TH because of the presence of substantial protected areas. Okay, kind of okay, there's a big potential for rescue effect here, so we brought her down a notch, the risk. So Laura said, how many of these things that lay off the diagonal was there a statement like this? And in about half the cases, okay? And I won't go into the particular patterns here. There's all kinds of interesting things of different species and so on and so forth. That's not what I really want to emphasize. What I want to point out, though, is that of those two different classes of cases of status reports where the algorithm returned a different answer than Kosiewicz, there was a significant probability of being uplisted, up designated, up designated with less quantity of information. So the fewer values or the more that were declared uncertain in the status reports, the greater the probability was that the species would be up rather than down designated compared to the algorithm. This is perfectly all right because, as Marty said, you know, they're mandated to operate under the precautionary principle, right? So we're taking a step to reduce the risk in the face of this kind of uncertainty. Fair enough. I will point out that you see, but this is that half right there. I mean, they have a high probability. It's basically chance whether they're going to end up on or off the line anyway. So there's a high chance of being off the line, and that chance increases with decreasing amount of information. We don't even deal with quality yet here. This is just amount of information. For the others, it's the exact opposite. And we'll be damned if we can figure out why that would be the case. So if anybody's got any insights to why the less information you have, for the ones that didn't have an explanation for why the designation, why there might be a change, right, that they were more often to be down than up designated. That we actually thought the pattern should be the same. And I can't for the life of me, you know, so maybe, you know, I mean, this is all probability and statistics, so maybe this is just weird. You know, it's just one of those chance things. We can't, small chance, but still chance, maybe. So there's just a review of why am I going to get these bugs right? So in half the cases of all of them, you know, the algorithm generated a different designation, but they were as often up as down. In half of those that differed, we could find evidence in the status report that it was explained that the committee had decided it would be different than what the quantitative data alone would trigger. And we have these two different responses in terms of probability with respect to the amount of information. So the question then becomes, how do we approach assessment and recovery in the face of this pervasive and complicated effects of uncertainty? So here's where it gets really fun. I've been sort of toying with this. This is only, I don't know what the difference between metaphor and analogy is. This certainly isn't a high-powered, intellectual kind of analytical go at this business, because I don't virtually know anything about law. What you see about law here, I learned from Law and Order as the analogy about how evidence is treated, or you could claim I did. But as evidence-based ways of knowing, science and law share some similarities. There's the balance, symbolizing the measurement, strengths for a case or not, like what is its risk status. The blindfold, symbolizing impartiality. We heard Marty talk about how all these volunteers come to the committee and they don't represent anybody. They're supposed to be impartial and not talk about socioeconomic consequences and just deal with the issue of risk, right? And the sword actually there is supposed to represent reason and justice, but I don't know what a sword's got to do with reason and justice. I don't know if I would be on the end of a sword if somebody thought they were dealing out reason and justice, so I took that off. But anyway, so much for the Romans. The law, it was the justice of the Roman Empire. Those symbols are actually added later to an earlier Greek version of the justice, apparently. But, that's the extent of my humanities wanderings. In law, we have judges and juries who take part, but don't take sides, or at least aren't supposed to. Like, we champion this as part of our law system. We're appalled if we think juries and judges are biased, right? We take great care to make sure about the impartiality. The advocacy is done by lawyers who know both sides of the case, but whose job it is to tear the other side down and put this side in. Right? Make sure your side wins. On the science side, we have scientists, and this might get a lot of discussion about the role of science in society and whether we abrogate our responsibility when we make our preferred policy statements and demonstrate our bias, and there's a whole literature on that. I'm going to declare myself on this side. Okay? We take part, but we don't take sides. Somebody has to be the judge of the evidence, right? While trying to be impartial. I don't think we might have scientists who behave like this on this side of it, but I think there's no direct counterpart except perhaps stakeholders with interests, vested interests in the outcomes of analysis. They will put forward their best available science will be the one that supports their preferred policy option, not the other side's preferred policy option, right? This logic system is retroductive. I'll explain that in a minute. And this one is hypothetico-deductive. Now, I'm not going to get into it. I've been punished by the philosophers of Guelph to not say the scientific method. So I did not say the scientific method. Tweet that out to the guys at Guelph, please. They'll be so happy. So here's a scientific method, okay? And it's the one you're shown in grade 4. It used to be in the Canadian school system when I was in it. And then somebody forgot all about it until you got to some kind of philosophy class in university. And that's how we've really bunned up teaching science. But that's the subject of another talk. But basically the way we understand the world is through a series of filters that determine the observations we make, our background, our assumptions of what they mean. And we like to generate hypotheses about the states of nature and the causes of them. And then we generate predictions, we test those predictions, and then we revise the hypothesis, we revisit assumptions, or maybe we even question our initial observations if things don't match up. There's been a lot of debate about whether inductive or deductive logic matters better. I don't get it. I'm here to declare as a practicing scientist, I just don't get it. I can't do good science without both of them. So this is the specific to the general. There's the general to the specific. One's induction, one's deduction. There's different risks associated with inferences if you stop anywhere along this cycle and don't know you're doing it, which can make bad science accumulate in the literature, bad information, unreliable knowledge. But that's, again, subject of another talk. What I want to talk about the workhorse of law is retroductive logic. We take some evidence from a crime scene. We get an indictment and a charge. That's induction. Right? And then we go straight to conviction. Think about it. Do we put an ankle bracelet on the perp and let him go back out and test our prediction he could have been the one that did it? Oh, of course we don't, because the risk is too high, right? So on the one hand, the risk, society won't accept that risk, right? So what do we accept? We accept a tautology. No scientist would ever stake their reputation and so forth and the quality of their science on a tautology, which is going back to the evidence that generated the hypothesis to prove its validity. This is biased towards type 1 error because it's a tautology. Now, we have checks and balances in the law system, right? I mean, we have the rule of thumb that better 10 guilty go free than 1 innocent go to jail. That's forcing the type 2, I think, to balance it. But I wanted to carry this further, and I've actually asked some environmental lawyers to help me actually study this, but so far they won't do so. So there's our workhorse. Assessment, listing, and recovery. More like law than science. Maybe that shouldn't surprise us too much. I mean, there's scientific input, but at the end of the day, after it goes through the system, right, who's thinking about this in terms of writing laws and regulations and everything else? I'm not saying that's the reason that we end up with this, looking more like retroductive logic and hypothetical deductive logic. There's probably lots of things at play, but the important thing is these things are missing. These things are missing. To different extents in different recovery plans. You can find evidence of this in different, for example, the woodland caribou recovery strategy and the scientific advice was just heaped in adaptive management. Okay? And so there are some examples out there. So the question to us is, how do we make assessment, listing, recovery planning, invitation more science-based? How can we restore those things that set us apart from committing errors of tautology in our logic and improving the reliability of the knowledge upon which we make these very important decisions, but somehow engage the very people at the same time who are the reason that things don't happen quicker after we get done the scientific assessment. So that takes me to the next. To do that, I want to tell you what I mean by science-based conservation, real quick. You can have the dictionary definition of science, knowledge and law, facts verified by exact observation, etc. Science here, here's one model of the relationship between science and policy and management. You hear lots of people talk about how science influences policy, policy drives management. This is a linear way of thinking about things, okay? The thing I want to point out is that there's two things there, knowledge and verified, okay? So we got a noun and we got a verb in the same definition. This is both, this is like any knowledge system, including ATK and other knowledge systems of regular people, okay, about revising knowledge and updating it with new information. Okay, so process and so forth. Management implies direct control, top-down control, and policy is this thing that links these two. So now friends in policy divisions tell me that they think about, so there are two levels of policy. Here's where we express our values maybe, right? We'll let the people have a sustainable harvest of polar bears. Here's the little p policy. What's the harvest rate that's consistent with getting that answer? Let's call this linear model learning then doing. And just to show you, the view from one policymaker in MNR who held this sort of view, here's our science feeding into the policymaker, along with just one more thing that the policymaker has to take account of and everything else, right? And there's three problems with this model. The science is vulnerable to use as alibi by policymakers. I'll point to examples of that. Abuse by stakeholders to influence decisions. Examples of that. And constant change. There's the scientific problem. It's constantly changing. So every age is considered itself the age of reason, yet hard facts tend to melt away to be replaced by new hard facts. I love it. Lewis Thomas, from his book, Late Night Thoughts on Listening to Mahler's Ninth Symphony. Adaptive management, in contrast, is learning while doing. It's done when you're trying to achieve the dual goals of management objectives and gaining reliable knowledge at the same time. So it's not this, and science in the sense of product by which we glean what we want to influence policy, and so it's this. policy as hypothesis, management as experiment. Policy is to hypothesis, right? So how are we going to, there's the adaptive management, almost done, Al. Adaptive management, policies, models, management feedback. You know, this is by and large done by technical people, maybe with the help of citizen scientists and so on and so forth. That's fine. You can't expect everybody to be engaged in that. But here we have this other feedback loop, this double loop learning model where the knowledge that comes out of there goes out into the broader community for assessment knowledge. They're kept apprised of what the scientists are doing. There's no black box. They're involved. They're involved in generating the questions, co-development of questions, co-development of management strategies. Critical uncertainties of all the parties are devised as part and parcel of the management plan. So we do the experiment, we manage as we go. Manage in ways that help us to learn and speed up that learning feedback loop. So we don't learn 25 years too late, we did something wrong. So who's engaged? Policymakers open to institutional change and stakeholder input. Well, I'm an academic, right? So we can all dream. Angos in industry open to objective dialogue with each other as well as to government. Resource managers open to management experiments. Not managers that go, oh, those pointy heads, I know what I'm doing. And a lot of, in this model, a lot of responsibility on scientists to get out of their silo and do science with everybody. Okay, this is collaborative, active. This is collaborative decision analysis and adaptive management, and what I'm proposing is that this is assessment, that's recovery, and as part of that new world that Justina was describing, we might actually think about the process that we put in place to deal with these issues of stakeholder disengagement and surprise down the road, resourcing, people were talking about, more parties, more resourcing, not just resourcing in terms of money, but harnessing all the collective brain power in the collective learning effort. And that's all I got to say. Thanks. Hope
Save some time for me because I have a question. So, does anyone have a question at hand, or if not, I will ask a question first. Okay, so, well, who has a question? Go ahead.
So hasn't adaptive management been around for a long time?
Oh, it's been, well, as far as I know, the first formal introduction of it was by Halling and Walters in 1976. And maybe Halling in 74 in another paper that's a little more obscure. Absolutely. But it was around before that in engineering. Decision analysis has its deep roots in business. In the first of Carl Walter's books on adaptive management, decision analysis appears as a chapter within a whole book on adaptive management. But what's happened over time is it's kind of come up to occupy this place together, okay, because the whole point of this decision analysis is that it has to be done collaboratively with stakeholders in order to facilitate that quicker learning and so forth that we're talking about. So now, I mean, there's whole literatures on this that have sort of spun back out of the conservation literature about using Bayesian belief networks, Bayesian decision networks, and so forth to actually help stakeholders model their problem.
Sorry, I meant, has it been implemented?
Oh yeah, there's examples of it all over the place. I'm always quick to point out in these things that people will say, oh, Nudds, you know, even Walter said, you can't do it. I said, no, Walter did not say you can't do it. Walter says people don't like to do it. People have a hard time breaking out of their institutional, okay? Don't tell me Carl Walter said we can't do it. He never said it, period.
Tell us what you really think.
Sorry, yeah.
Go ahead, please.
This is more of a comment than a question, if that's okay.
Please.
I really, really appreciate what you're working on here. And I just wanted to suggest that I felt you're going back to your science versus law comparison.
Okay.
Was something of an unfair comparison.
Okay.
Partly because it comes out of criminal law.
Well, yeah.
Extremely adversarial thing.
Sure.
Whereas if you'd looked at judicial inquiries, for example, where the role of the different advocate really is to test the evidence. So it's somewhat analogous to peer review in that sense. And the evidence is being tested. And then,
Okay.
as an anthropologist.
But my metaphor about putting an ankle bracelet on the perp, wouldn't
Well,
make the
yeah.
quite so dramatic.
But,
So much for that little device. But I take your point. Yeah.
As an anthropologist, I'm also in that position where I can't run experiments on the
Right.
people I work with. And I don't want to, it's not as if I'm deprived. But I am working with speaking human beings of whom I can ask questions that I could never ask of a biosphere or something. So
Sure.
maybe a little bit more attention to
Thank you.
the kinds of ways in which, because I think in a way your initial gesture was to pull them together and show that they're not wholly disarticulated kinds of systems.
No, they aren't. But I did want to point out that, and maybe it only works in the criminal law analogy, that what is missing is, or what characterizes it is a tautology and not a further experiment, right? We go back on the evidence that generated the hypothesis of guilt, right? That's not to say that during the course of investigations, people don't go, well, if the person really did it, we should find more of the DNA at the other site. And so, there's a bit of hypothetical deductive hypothesis and prediction generation that goes on, okay? But in the end, it's still observations that come from the field that generate the hypothesis, and in a lot of cases, I guess the bulk of it, the bulk of the conviction still rests on what generated the hypothesis, and that in science is called a tautology. We look for that stuff. And it's really unfortunate how common it is once you know what you're looking for in the scientific literature. It jumps out and it's staggering. That goes back to that teaching science thing I was complaining about before. Sorry. Justina.
Hello. Can you go back to that slide where you were comparing the law and science?
Sure.
The one that was just being talked about.
Yeah. The table or the...
No, the diagram.
Sure.
Yeah, there.
Oh, there, okay.
Yeah, that's good. So, if you looked at how, so I'm a simple and linear person. If you look at at how the act was designed, you could make a case that it is designed this way, in the sense that the status is a hypothesis that gets tested out there. As soon as you put it out there, and that is, I do think functionally it is. There are those that, there are people that are, with some species, not everything, but looking at sort of constantly collecting more information and testing that, both as times change, but also perhaps it was gotten wrong. And certainly when it comes back to the placebo table,
Oh, yeah.
you sometimes find out it's wrong and then there's an adjustment because there's new information.
Sure.
So,
Yep.
so you have that part. Also, if you actually did recovery, that would also be part of that cycle. So my question then goes deeply into practical stuff. Given the act was designed, and I haven't gone into all the details, but I do think it's more like that than you're saying. In design, but absolutely not in practice. What would you how do you design this in terms of the assessment? So the way
I would, oh, I'm sorry.
Well, but you have to, because
Yeah, no,
you have to.
I should let you finish. I'm sorry.
No, in terms of, yeah, you wouldn't design the details, but you have, what kind of, give us a little bit of thought beyond the last graph where everybody's swirling around together. How does that work in terms of the assessment and tell me.
Okay, well, the first thing I do is I would forget this notion somebody talked earlier about, so I think was it Arnie? So who mentioned socioeconomics as the drivers, and it did make sense? Yes, Matt. I mean, if we want to be science-based about this, I think it's patently unfair that if, we're going to be science-based. Science is about how we reliably understand states of nature and their causes. This process, however, results in a status report that I think is as well as it can be without further stakeholder knowledge, eliciting more expert opinion than is only in the COSEWA committee, does a good job of assessing the state of nature. But it gets to list potential causes. It gets to list the threats are potential causes. It gets to list them, and then everybody moves off to recovery as if the conclusion is that thing is the cause. So we stop hay mowing, or we push it back, or we do something different kind of forest, or that have implications on real people, which you gotta understand, they're gonna back up. They're gonna back up on this. They don't like this model that some scientists somewhere, even if everybody else is invited and can come and watch and everything else, came up with this thing that's gonna affect, if you bring them along for the ride, then they're committed to whatever comes out the other end too. But then so are you. So my model is, we actually think about constructing the assessment process around workshops where perhaps we employ the tools of Bayesian decision networks, Bayesian decision analysis, where we engage in multi-stakeholder arenas to construct the conceptual model about what we think first the state of nature is and the causes of it, and then design the recovery strategy to address those things. And it sounds like a tall order. And you know what? It might be risky to start thinking about changing things, especially in this political climate and everything. I get all that. But I think there's a devil out there I prefer to know better than the one I'm living with now when it comes to this process. And you know, what are we doing if we're not scientists, if we're not going to go see what's over there? Could we really try this? The thing itself is that it could be an experiment. We could try some pilot projects, some assessments coming up. I'm not saying it's going to work, but I mean, why wouldn't it be worth a try? Anyway.
I think we're going to end it there.
Oh, you gotta let Marty. Good.
Quick, please.
I'm sorry. I didn't mean to take over his chair.
Quickly, please.
I would say some of that happens already. Those little expert committees, nobody's tasked with doing science. We don't have the budget to do science, to actually go out and collect the data ourselves.
Oh, of course,
I know
yeah.
what exists.
Yeah.
But a lot of this sort of using Bayesian network stuff, we have that stuff.
That's true. I didn't mention that. You've started that. Yep.
Yeah, those little subcommittees are doing some of what you're
Yeah.
actually, I take your point.
We need to advance that
Yeah.
faster.
All right, let's thank Tom, please, and then we have.